Hai, hari ni kita akan masuk chapter baru iaitu predictable periodicity. Okey, ini kita dah masuk kepada inorganic chemistry. So we starting with predictable periodicity. Okay, first we look at the physical properties. Okay, untuk tajuk ni kita akan tengok mostly on period 2 and period 3. Okay, first we have atomic radius, ionic radii, melting and boiling points, enthalpies of vaporization, electrical conductivity, and ionization energy. First, atomic radius. The diagram shows how the atomic radius changes as you go across period 3. Okay, here we have element in period 3, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, kalau awak tengok kat sini, the trend from left to right, okay, across the period, from left to right, okay, the atomic radius is become smaller. Okay, atomic radius decreases. So the figures used to construct this diagram are based on number 1, metallic radii for sodium, magnesium, and aluminium. Covalent radii for non-metals, silicon, phosphorus, sulfur, and chlorine. And the van der Waals radius for argon because it doesn't form any strong bonds. Okay. So when going across period 3 from sodium to argon, the number of protons in the nucleus increases by 1. This causing the nuclear charge to increase. Okay, so the nuclear charge is referred to the number of proton in the nucleus. Okay, remember in the nucleus we have proton and neutron. So proton, the positive charge, neutron is neutral. So increase in number of protons, therefore increase in nuclear charge. Next, the screening effects remains almost constant because the number of electrons in the inner quantum shells remains the same. Okay, disebabkan ini kita bincang period 3. So in period 3, all elements have 3 shells. Okay, the same number of shells. Okay, for the first shell and second shells, the number of electrons is the same. Okay, the difference is in the outer shells. Okay, that's why the screening effect remains almost constant. Okay, therefore the electron clouds are being pulled closer to the nucleus, causing the atomic radius to decrease. Okay, so ada attraction between nucleus and electron, different charge, menyebabkan atomic radius to decrease. Okay, become smaller. Okay, next ionic radii. Okay, dekat sini kita ada sodium, magnesium, aluminium, sulfur, and chlorine. Okay, this is some example element in period 3. Okay, so here the pink color is sodium ion, and the beside that is sodium atom. Okay, for sodium atom dia akan release electrons to become sodium ion. Okay, compared to anion, okay, we have here sulfur and chlorine. Okay, to become an ion, the atom will receive electron, okay, to become ion. So the anions are larger than the cation. Okay, kalau kita tengok size untuk anion, okay, the negative charge ion is larger than cations. Okay, this is because the anions have 3 shells that are filled with electrons, while the cation have only 2 shells. Okay, macam sodium. Sodium atom, there are the 3 shells filled with electrons. Okay, when it's release 1 electron, okay, so tinggal 2 elektron, 2 shell sahaja. Okay, untuk sodium ion. Okay, compare dengan chlorine. Okay, chlorine dia ada 3 shells. Okay, when it become ion, masih lagi 3 shells. Okay, dia tak berkurangan bilangan shells tu. That's why an ion has a larger size than cation. So the size of cations and anion going across the period is decreases. Okay, tak kisahlah ion yang mana, anion and cation, dua-dua size semakin berkurangan. Okay, when going across the period from left to right. Okay, this is because all the cations and anions are isoelectronic, but the nuclear charge increases. Okay, cation and ions are isoelectronic. Isoelectronic means same number of electrons. Okay, for example, sodium ion and magnesium ion. Okay, both have same bilangan electron, number of electron. Okay, untuk sodium ion dia ada 10 number of electrons, magnesium ion pun sama. But the difference is the nuclear charge. Nuclear charge we refer to the proton number. So proton number for sodium is 11. Proton number of magnesium is 12. Okay. Therefore, the nuclear charge for magnesium is higher than sodium. Therefore, there is more attraction in magnesium compared to sodium ion. Okay. Therefore, the attraction between the nucleus and the electron become stronger. Okay, there is 4 ionic radii. Okay, next physical properties is melting and boiling points. Here we have the diagram. Okay, the red one is the boiling point and the green one is the melting point. Okay, melting and boiling point rise across the 3 metals because of the increasing strength of the metallic bonds. Okay, for sodium, magnesium, and aluminium. Okay, the melting and boiling point increase. Okay, so increasing strength of the metallic bond, macam mana kita nak tahu yang mana lebih tinggi dia punya metallic bond, the strength of metallic bond. Okay, kita tengok the number of valence electrons. Okay, the higher the valence electron, the strength the metallic bonds. Okay, lebih banyak dia punya electrovalence, semakin kuat dia punya metallic bonds. Okay, the number of electron which each atom can contribute to the delocalized sea of electrons increases. Okay, ni maksudnya tadi lebih banyak electrovalence, lagi banyak elektron yang boleh contribute untuk delocalized sea of electrons. So the melting and boiling point increase because the nuclei of the atoms are getting more positively charged. The sea is getting more negatively charged. And the sea is getting progressively nearer to the nuclei and so more strongly attracted. Okay. Jadi maksudnya attraction dia lebih kuat. Jadi kita perlukan lebih tenaga, lebih tinggi suhu diperlukan untuk break the bond. Okay, next, silicon has high melting and boiling point because it is a giant covalent. structure, more energy needed to break strong covalent bonds. Okay, walaupun silikon ni non-metal, tapi dia punya melting and boiling point also high. Okay, because of its giant covalent structure. So, ini yang kita panggil giant covalent structure. So, phosphorus, sulfur, chlorine, and argon are simple molecular substances with only van der Waals attraction between the molecules. Okay, that's why the melting and boiling points are low. Okay, here we have phosphorus. This one is sulfur, chlorine, and argon. Okay, phosphorus P4 molecule, sulfur S8 molecule, chlorine Cl2. Okay, their melting or boiling point will be lower than those of the first four members of the period which have giant structures. Okay, next physical properties is electrical conductivity. Conductivity increases as you go from sodium to magnesium to aluminium. Okay, ni sebab dia metal lah. So metal dia boleh conduct electric. Okay, because of the delocalized electron. The sea of electron are free to move throughout the solid or the liquid metal. Okay, ini kedudukan sea of electrons. Okay, we have positive metal ions. Okay, and moving negative electrons. Okay, so electron bercharge negatif ni dia are free to move throughout the solid. Okay, dia sebenarnya boleh bergerak mengelilingi nukleus ni ya, dia sentiasa bergerak. So bila sentiasa bergerak, dia boleh membentuk sea of electrons. Okay, silicon is a semiconductor. Okay, it's a weaker conductor than metal, but better conductor than non-metals. Okay, the electrical conductivities are higher than non-metal but lower than metal. So none of the rest conduct electricity. Okay, for phosphorus, sulfur, chlorine, they can conduct electricity. Okay, next is ionization energy. Okay, ionization energy is the energy required to remove one electron. Okay, so first ionization energy is governed by the charge on the nucleus, the distance of the outer electron from the nucleus, the amount of screening by inner electrons, and whether the electron is alone in an orbital or one of a pair. Okay, yang last kali ni cerita pasal susunan elektron dalam orbital. Okay, kita ada yang 1s2, 2s2, 2p6 tu. Okay, bila 2p6 dia ada completely fill, yang itulah yang kita nak tengok nanti. Okay, across a period, the number of protons increase in the nucleus as you go from sodium across to argon. In fact, the increasing nuclear charge drags the outer electrons in closer to the nucleus. So, it increases the nuclear charge. So that causes greater attraction between the nucleus and the electrons. So increases the ionization in energies. Okay, so bila attraction semakin kuat, jadi kita perlukan tenaga yang lebih lah, tenaga yang tinggi untuk membentuk ion to release the electron. Okay. Trend in ionization energy across period 2 and 3. So we have a diagram here. Okay. First one, from lithium to neon, ini adalah untuk period 2. Okay. From sodium to argon, ini untuk period 3. Okay. So notice that the general trend is upwards, but this is broken by faults between beryllium and boron, nitrogen and oxygen for period 2, magnesium and aluminium, and between phosphorus and sulfur for period 3. Okay, jadi kalau kita tengok secara general, okay, the trend is upward. Okay, dia semakin menaiklah, cuma ada beberapa bahagian yang dia broken. Okay, jadi kita tengok the fall at boron and aluminium. Okay, so kita tengok sini, dia upward tapi ada slightly broken. Okay, dekat boron dengan aluminium. So boron electronic configuration is 1s2 2s2 2p1, aluminium 1s2 2s2 2p6 3s2 3p1. Okay, boron untuk period 2, aluminium untuk period 3. Okay, boron and aluminium in the same group. Okay, that is group 13. Okay, so here, okay, kalau kita tengok compare boron dengan beryllium. Kalau beryllium, dia ada 4 protons. Okay, jadi untuk beryllium, the electronic configuration is 1s2 2s2. Okay, but for boron, 1s2 2s2 2p1. Okay. So the outer electron is in a p orbital rather than a s orbital. Okay. Kalau beryllium tadi dia ada sampai s orbital sahaja, tapi untuk boron dia ada p orbital. And this p orbital is slightly more distant from the nucleus. Okay. So kedudukan p ni dia jauh sikit daripada nucleus compare dengan s orbital. Therefore, they are partially screened by the 3s electron as well as the inner electrons. Okay, ini 3s electron untuk aluminium lah. Kalau untuk boron, dia screened by 2s electrons. Okay. Jadi sebab tu dia punya tenaga tu agak rendah sikit sebab dia ada screen by the s electron. Okay, yang berada lebih dalam sikit. Jadi dia senang untuk dikeluarkan. Sebab tu tenaga tu rendah. Okay, next, the fall at oxygen and sulfur. Okay, oxygen for period 2, sulfur for period 3. So oxygen, the electronic configuration is 1s2, 2s2, 2p4. Okay, sulfur 1s2, 2s2, 2p6, 3s2, 3p4. Okay, yang ni sama macam boron dengan aluminium tadi. Dua-dua pun ada s orbital, p orbital. Okay, cuma bezanya dekat sini, untuk first ionization energy, kita nak remove first electron. Okay, jadi first electron kita akan ambil daripada p orbital ni. Okay, this one, p orbital. But in this p orbital, we have 4 electrons. So, which one we select to remove? Here. The screening is identical from the inner electrons. Okay, the electron is being removed from an identical orbitals. Okay, ini yang saya kata tadi, ada 4 elektron dalam orbital yang sama. Okay, ada 4 elektron. Okay, so 4 elektron ni kita akan isi 1 1 and another one is pairing. Okay, so 2 single electron and 1 pairing electron. So the difference is that the electron being removed is one of the pH2 pair. Okay, jadi kita akan keluarkan elektron daripada pairing electron first. Okay. So the repulsion between the two electrons in the same orbital make the electron is easier to remove than electron from half-filled p orbitals. Okay, jadi dekat sini bila kita ada 4 elektron dalam orbital yang sama, iaitu p orbital, kita akan susun dia single pairing. Okay, so bila pairing ni, yang pairing ni kita akan keluarkan dululah. Okay, sebabnya elektron dia bercharge negatif kan. So bila negatif dia akan repulsion. Okay, dia akan tolak satu sama lain. So lebih mudah untuk dikeluarkan. Okay, easier to remove. Okay, that's why dia punya energy dia decrease lah dekat sini, dia broken. Okay, untuk oxygen and sulfur. Okay, trend in ionization energy down group 2. Okay, untuk group 2, dia punya trend is decrease. Okay, maksudnya bila menuruni kumpulan 2, lagi senang elektron tu untuk release. Okay, lagi senang untuk dikeluarkan. Okay, jadi kita tak perlukan tenaga yang tinggi lah untuk remove the electron. Why? Because when going down a group, the radius of the atom increases, so the distance between the nucleus and the outer electron increases. Okay, bila menuruni kumpulan, okay, dia punya number of shell pun bertambah, menyebabkan atomic radius pun bertambah lah. Okay, bila atomic radius bertambah, dia punya distance, jarak antara nucleus and electrovalence semakin jauh. Jadi bila jauh, lagi senanglah untuk dia release. Therefore, the force of attraction between the nucleus and outer electron is reduced, become weaker. And less energy is needed to remove the outer electron. Okay, similar explanation as you go down the other groups. Okay, group lain pun samalah explanation macam ni jugalah. Dia punya when going down the group, the atomic size is increased, therefore the attraction between nucleus and electrovalent decrease. Okay, less energy needed to remove. Okay, the electron valence become easier to remove. Okay, successive ionization energy. Okay, successive ionization energies provide evidence for the existence of electronic shells. Okay, macam mana? Okay, example here, the first 4 ionization energies for aluminium are given by. Okay, kita ada aluminium, first ionization energy, second, third, and fourth ionization energy. Okay, this is the value of the energy. We have 577, 1820, 2740, 116. 0 kilojoule per mole. So from this ionization energy, so in order to form an aluminium ion, okay, Al3 plus ion from aluminium, you have to supply, okay, this one is the first ionization energy, second and third. Okay, therefore, untuk membentuk aluminium 3+, Ion, kita perlukan 5137 kilojoule per mole energy. Okay. So the fourth ionization energy is huge compared with the first three. Okay. Jadi the first three dia agak beza dia tak jauh sangat lah compare yang keempat. Bila dia ada huge difference, okay, perbezaan yang sangat besar menunjukkan dia punya tenaga yang diperlukan untuk mengeluarkan elektron tu sangat tinggi. Okay, menunjukkan dia berada dalam shell yang berbeza. Okay, so the fourth electron is removed from the shells, which is much closer to the nucleus. Nah, bila dia elektron tu semakin dekat dengan nucleus, attraction semakin kuat, jadi kita perlukan tenaga yang lebih tinggi. So, position of unknown elements in the periodic table from successive values of ionization energies. Okay. For example, here magnesium 1s2, 2s2, 2p6, 3s2 in group 2 of the periodic table and has successive ionization energy. Okay, 7, 3, 6. Okay, this one is the first ionization energy. Second, third, fourth, fifth. Okay, first and second, 7, 3, 6, 1, 4, 5, 0. Okay, third ionization energy is become huge. Okay, kalau 1450 dengan 736, difference around 700. Okay, plus minus 700. But from second to third ionization energy, okay, from 1450 to 7740, the difference is around 6000, which means there are huge difference from second to third ionization energy. Okay, from third to fourth, okay, dia around 3000. Here pun samalah, around 3000. Okay, so they have big jump in ionization. Okay, jadi kita boleh buat conclusion, this one, first and second ionization, so these electrons are lost relatively easily. Okay, compare to the rest, the electrons are much more difficult to remove sebab dia dah berada dalam shell yang berbeza. Okay, electron dia much closer to the nucleus. The big jump occurs after the second ionization energy. It means that there are two electrons which are relatively easy to remove. Okay, the 3s2 electrons. Okay, the third electron is much more difficult to remove. This is because it comes from an inner level which is closer to the nucleus with less screening. Electronic configuration can be determined using graphical method. Okay, for example here we have chlorine. Okay, ini secara dalam bentuk graf lah. Okay, first, second, first ionization energy, second ionization energy. Okay, first, second, third, fourth, fifth, sixth, seventh. Okay, this one is from the same shell. Okay, jadi untuk electronic configuration here for chlorine. So chlorine has the electronic configuration. Okay, 1s2, 2s2, 2p6, 3s2, 3p2, 3p2, 3p1. Okay, jadi dia ada 2, 2, 1 here. Okay, jadi untuk keluarkan elektron, okay, first electron to remove, kita kena keluarkan daripada pairing electron. Okay, pairing electron. So, pairing electron ada 2. That's why sini pun ada 2. Okay, pair 3p electrons. So, bila elektron yang pairing kita dah keluarkan, so tinggal single unpaired elektron. So, ni unpaired elektron ada 3. Okay, daripada unpaired elektron, so dah habis, baru kita keluarkan daripada 3s elektron. Okay, 3s elektron masih lagi dalam shell yang sama, sebab tu dia punya perbezaan dia tak jauh lah. Okay, compare dengan p elektron, okay, dia sangat jauh dia punya perbezaan. Okay, menunjukkan ada perubahan shell. Okay, contoh yang kedua, ini adalah aluminium lah, 3p, okay. So, kita bermula dengan 3p, okay, kita mula dengan 3p sebab kita nak keluarkan elektron. So, nak keluarkan elektron, kita kena ambil elektron yang paling terluar sekali, electrovalence, yang paling jauh daripada nucleus. Okay, kalau kita buat electronic configuration, kita susun from 1s, 2s, 2p, 3s. Okay, tapi ini ionization energy, kita nak remove the electron, so kita mula daripada belakang lah. 3p, ts, okay, 3p ada 1 electron sahaja, 3s dia ada 2 electron, okay, 2s, 2p, and 1s. Okay. So, thank you. So, sampai sini dia punya physical properties untuk period 2 and period 3. Okay. Thank you.